These are the answers for the worksheet for Chapter 8, which deals with the topic of lipids. On item 1, we need to classify the following lipids as either fatty acids, wax, glycolipid, triglyceride, phospholipid, sphingolipid, or steroid. Let's go through each molecule. Okay, so the first molecule that we see, it is called a fatty acid because it has a long chain of carbons and a carboxylic acid. The molecule below it, that is a glycolipid, because it has a sugar motif. The molecule below that one, so the third molecule in the first column, that is a steroid. In the fourth molecule in the first column, that is a sphingolipid. Let's move on to the next column. In the next column, the first molecule that we have is a phospholipid. The second molecule in the second column, that is a triglyceride. The third molecule in the second column is another fatty acid. In the last molecule on the second column, that is a wax. Let's move on to problem 2. As you can see, it says label the following fatty acids as either saturated or unsaturated. The definition of a saturated fatty acid is going to be one in which it has the carbon atoms fully bonded to hydrogens past the carboxylic acid functionality. So the molecule that we have on the right, that is a saturated fatty acid. An unsaturated fatty acid is going to have one or more alkene motifs. So that's why the molecule on the left is an unsaturated fatty acid. Let's move on to part 3. Now, in biochemistry, we typically label many biomolecules as cartoons just because they are large in size. So the label that we have for number 3, this is specifically how we draw a phospholipid. Now, as you can see, it says label the polar and non-polar ends of this representation of a lipid. So the two lines that we see here, I'm going to highlight them in yellow. So the two black lines that you guys see, that is going to be the non-polar ends. Because that's going to be the part of a phospholipid that is going to contain carbon hydrogen atoms. There could be saturated or unsaturated, but that's the part of the molecule. The red ball is going to be the polar end. So this polar end is where we have the amino alcohol in the phosphate part of your phospholipid. On item 4, we are going to outline what are the main functions of lipids specifically in human. The first function of lipids in human is going to be provide energy, storage. The second function in humans is going to be providing biomolecules for cell membranes, the third function of lipids is going to be act as chemical signals, and the last function is going to be that it is involved in protection and insulation of neurons. Let's move on to item 5. In item 5, as you can see, we're going to be predicting the products of saponification. Saponification is when we take a triglyceride and under basic conditions, we are going to hydrolyze it. Okay, so the hydrolysis of a triglyceride produces, and I'm writing the skeletal structures of my products, an alcohol. In this case, is going to be glycerol, and is going to also produce a carboxylate. In this case, is going to be the carboxylate that is part of the fatty acid chain that is in this triglyceride. And understand that specifically because it has 16 carbons in, it is saturated fatty acid. This is palmitate. On the last part of this handout, we are going to identify the different components in cell membranes, and you have to select from the list given. As you can see, you have protein channel, hydrophilic head group, glycoprotein, fatty acid tail, glycolipid, phospholipid molecule, cholesterol, lipid bilayer, peripheral protein, carbohydrate side chain. So this is just a cross section of a cell membrane. So let's label the different components. Letter A is a phospholipid. Letter A1 is going to be the hydrophilic head group, which means that it's going to interact with water. A2 is going to be the fatty acid tail. Letter B is going to be a glycolipid. Letter C is the glycoprotein. Letter D is the carbohydrate side chain. Letter E is cholesterol. Letter F is a peripheral protein. Letter G is a protein channel. And the region H through I is a lipid bilayer.